Hi, everybody. Welcome to the last couple of sessions at Spring IO 17. Everybody had a good time? Yeah, it's been a good show. It always is. If you don't know me, I'm Dave. That's my Twitter handle if you want to be angry afterwards. If you don't want to be angry, that's also good. Feedback is good. Actually, one of the reasons that I wanted to present this is because we always get good feedback. So please, this is something new, so keep your ears open. Try not to nod off, and ask me questions and tell me what you think afterwards, because I haven't shown this to anybody else, right? You are the first people in the world, actually apart from maybe a handful of people in London I bumped into once. This is the first conference, the first show where we've started talking about this new thing. In fact, I think when I made the proposal to this conference, I think the title in the program is probably "The Road to Serverless Functions as Applications," which is also a good title. But I replaced that last bit with Spring Cloud Function, because we are going to have a project, and I'm pretty sure that's its name, so I might as well call it that. And so I'm here to talk about that, to tell you what that's about, getting into what is serverless, why do people use it, what does it mean, and mainly what does it mean if you're a Spring developer, right? If you're building applications using Spring and you've heard about function as a service or serverless, what does it mean for you, or what could it mean for you? So I can start with a little bit of background theory, get everybody on the same page. What do I actually mean? What do people mean when they say serverless? Obviously they don't mean there are no servers, because that would be stupid. But it does mean something. And it's really a level of abstraction, so it's kind of the sort of top of the pyramid. And I think what we'll find is that if we think about it the right way, then it's obvious, at least to me, that Spring and Spring developers have a lot to offer in this area. So I want to cover that, just the background and the sort of setting the scene. I want to show you what we have at the minute in Spring Cloud Function, and talk a little bit about what we might have by the time we release something, sometime this year probably. And one of the themes that I hope will emerge as we go through it is one which actually my big boss in Pivotal uses a lot, which is the value line. How many people have heard of the value line? It's an interesting one, because it was invented to explain why you need a cloud, right? What does that mean? So it's all kind of about what you care about as a developer. So as a developer, I personally don't care about containers. Really don't care. I want my app to run. If it runs in a container, that's fine. I don't care. Somebody can do that for me. So containers I consider to be below my value line. They don't have any value to me. They have value to somebody, so somebody's going to sort them out for me, but not particularly to me. So I mean, a more extreme example would be, everybody heard about the Windows hack last week, right? If you don't update your operating system, if you don't apply those security patches, then you're sticking your neck right out. Okay, so I do care about that, but only in an abstract way. I want the operating system that I run on in my app to be patched. Do I want to patch it? No, absolutely not. All right, so that's below the value line. And I think what we'll see with serverless and functions is that we're sort of raising the value line another notch from what we were talking about before we had those features. So let's see a picture that sort of explains that in more concrete details. So this is a diagram I borrowed from one of my other colleagues at Pivotal called Mark Kropf. And so he does this thing where he talks about where the pivotal technologies map onto these abstractions. I don't need to bother about that today. I just want to explain what the abstractions are. And it's related to this value line, right? So at the point where you cross a boundary in this diagram, you've pushed the value line down to somebody else. So at the bottom, you might start off with virtual machines. That's even below that, I guess you've got bare metal, right? Some people start the presentation that way. Well, these days, virtual machines are kind of, they're almost a commodity, right? Nobody really cares about them anymore. But somebody has to provision them, patch the operating system, do all that hard stuff, hopefully automatically, hopefully completely out of my control as a developer. But there are abstractions that help you deal with that, right? So keeping your platform running, keeping your machines running, and keeping them patched is a valid concern. You want to automate it. You want to have tools and platforms for it. So we have abstractions that cover virtual machines. So an example would be the Google Compute Cloud has a provisioning system for virtual machines. Amazon has EC2 and lots of things, lots of tools around EC2 to keep your virtual machines alive and healthy. The layer above that has only sort of recently become a mainstream concern, I guess. It was always sort of there. Everybody knows that containers are not new, really, but they have sort of been very, very much, I guess, highlighted and showcased because of the kinds of abstractions that people have in this layer now. So actually, in this layer, we're talking about things like Kubernetes, I guess. It's container orchestration, managing your containers and putting them in the right place, and if they die, bringing them back and things like that. Because a container on its own is kind of useless. And then the layer above that, we're talking, this is now starting to get me interested. Okay, the layer above that, we're talking about apps, applications. I write my code in Spring. I want it to be able to run on my laptop. And then I want it to be able to run wherever I send it, whether it's Amazon, Google, my internal VMware cloud. It doesn't matter. I just want it to run. So if my value line is below the application level, I'm happy as a developer. But I've still got to deal with some integration problems, right? I've still got to sort of wire up my application to a database, and I've got to think about service discovery and authentication and quite a lot of things that are basically not business concerns, right? And that's the fundamental point here. Apps are great, but they do have to get a little bit messy. They have to get a little bit into the weeds with integrating with other things. So I think that's where I'd like to introduce functions, and the role of functions as an abstraction is really this. A function is something that transforms data, right? It has an input and an output, or sometimes it's just an input, or sometimes just an output, but basically an input and an output, and in the middle is some business logic. So a function is a way of expressing business logic without any of those other concerns, all right? Nothing below there is anything I need to care about if I'm writing a function and deploying it into one of these serverless platforms that now exist. So if you're sort of paying attention, and if you've been using Spring for a while, you've probably heard me and other people talking about Spring in that way. Spring is what you use if you want to write business logic and have everything else kind of magically taken care of. All right? Does that sound kind of, that resonates, right? That sounds like a message that people understand. So that tells me that, Mike, I've been talking too long. That tells me that Spring has something to say here. Spring has a way to present itself to a function developer that will make sense. So here's the same diagram, but with the as a service acronyms attached to them. You've all been familiar with, definitely, infrastructure as a service at the bottom. Container as a service is sort of, it's a bit shady, a bit hazy thing, but it's basically, if you could provision Kubernetes on demand, that's what it would be. Yarn, I guess, is a bit like that as well, although it doesn't specifically deal with containers. And then platform as a service on top of that. Lots of people have been talking about platform as a service and trying to spin it and define it, and it's a little bit slippery. To me, it's I write the application and the platform takes care of everything else. And then you've got this new thing, which is, taking off in quite a big way, called function as a service, and that's where you write just a function, a very small unit of work, and deploy that as a single deployable thing. Function as a service. So, some people call it function as a service, some people call it serverless, which is, like I said, ridiculous, because obviously there are servers. It's just that you don't care about the servers as the developer. So here's my sort of bullet point list of what I think is important about serverless. It makes you think about things as event-driven. Okay, so you probably wouldn't be using it if you didn't have some kind of events to listen to. An event can be quite generic, though, so it could be something like an HTTP request. You can turn that into an event. It's all about dynamic resources, scalability, efficient utilization of resources, because the way the platforms work, this isn't to do with the functions, really. This is to do with the way that the platform handles the functions. You can be very efficient by essentially shutting down apps that are not busy. And the serverless providers kind of have very kind of hazy, but actually fairly strict requirements about state. You have to be completely stateless, pretty much, because they can kill you at any time and then start you back up again. Billing is an interesting one. So there's a good piece by Simon Wardley, I think it was, sometime last year. If you search on Google, you'll find it, about how actually the billing model transforms the way you do business. And the billing model for serverless is per execution. It kind of can't be anything else. You pay for the number of events that you consume, which is sort of interesting. And it makes you think quite hard about which functions, which features are important to you, because they're the ones that are being used the most. Right? And they're the ones that you care about. If you've got a function that you can actually easily measure is hardly ever being used, you can more easily evaluate whether you want to change it or not. So billing per message, I think, is sort of, it's not just finance, right? It actually does transform the way that you potentially think about your software and the way that you make decisions about what to implement and when to implement it. Yeah, so the next bullet point, there's an interesting one. This is sort of anecdotal, but people who I talk to who use serverless, like in anger, they actually build apps. This is their experience. So they've said things like, well, we had an idea, and we found that we could just write that idea down really quickly in JavaScript or whatever, right, in some function that transforms data. And you know what? You can deploy that within seconds. You're up and running on Amazon Lambda or Google Compute or whatever you want to do it. So you get very, very fast turnaround time for prototypes. And then so these people who are talking to me about this, I'm trying to work out why they do it and what's important about it. And then they said, and you know what? It was with a normal application, quotes, normal, we would have rebuilt it from scratch, put it on a proper platform, tested it more thoroughly and stuff like that. With this one, we just left it there, and it works. You don't have to care about anything else. The platform literally covers everything that you want: monitoring, logging, alerting, billing. It's all just there, and you know that it's always going to be there. So your prototypes become production code extremely quickly, and you can just forget about them. There might be a flip side of that. There's another interesting thing I saw last week was a little article, a blog on, is Serverless the new Visual Basic? And all the people who are laughing know exactly what I mean. So Visual Basic was a tool that we gave to idiots because it was easy to produce Windows user interfaces, and then they made a big mess, and we were we were surprised. Well, not, but so I don't think the VB is. I don't think serverless is directly like VB. I don't think it's something you give to idiots, and that you don't have things like, buttons with event listeners that you can. You can't sort of mix things up too much in a function, because there's nothing, there's no state, right? There's just the event coming in as what you send out again. There's nothing else. So it's probably not as bad, but it's an interesting observation that VB was a big mess at the end of the day. And we have to be careful about things like that. And so then the last thing, which I've already said, is you focus on business logic. And if that doesn't make it sound like Spring, then it should do. And I'll show you what I mean by that in a minute. So getting back to that theme, business logic, and then bringing in the value line, explaining what I mean by that in a different way. Adrian Cockcroft coined this term undifferentiated heavy lifting when he was at Netflix. Well, that's the thing that you want to avoid, right? So it's, upgrading, updating operating systems and creating virtual machines and, infrastructure. So what you want to do if you want to be successful as a software business, and everybody does, is not do that. You want to write business logic and then get out of the business of the infrastructure and the automation around that. Delegate that to somebody else. And so what serverless is giving you is an extra kick in that direction. So undifferentiated heavy lifting now also includes anything to do with integration, gluing things together. That gets done somewhere else in a platform. So here's a screenshot. You can probably read it all. The sort of punchline of this is that Amazon has this thing called Lambda. Anybody tried it, by the way? Yeah, a few. Good. Okay. Which runs your functions. It's really cool, right? You register a function, then you can separately create triggers for it. So your triggers could be HTTP incoming requests, or in principle, S3, maybe if S3 events, if a file is saved or updated, it'll ping you with that. Or you can get just generic messaging from Kinesis. So there's a bunch of different ways of triggering your function, your business function. And the way you set it up, which is sort of the bad news, is this, right? I mean, it's a bit sort of, this is why it's VB, because it's designed for people who like graphical user interfaces. Of course, there's an API behind it, okay, and a command line tool. So, we're not completely finished. We can integrate these things into our development pipelines, but it's a little bit, it's a little bit loose because of the kind of drag and drop style of it. The fact that you have to sort of stitch everything to all your integration gets done in this graphical user interface. The other problem is, I forget what the other problem is. I'll come back to it. This is the VB point basically, sort of made fairly loud and clear. And you can tell from this picture that they support Java natively. So there's a runtime drop down here. And I've selected Java 8, and I'm going to upload a jar file. So if you haven't tried it, you can imagine what it's like. You just upload a jar file. It's like a shaded jar with all your dependencies in it, if you have dependencies. And you, actually not on this screen, but lower down the screen, you would see you can specify a handler. So you basically say class name and method. It's a method reference, and that's the Lambda. So it's a Java 8 function, essentially. It's a method. Same sort of thing happens in Google. Just to prove it, there's a screenshot. This is a screenshot of a proof of concept that we did just to make sure we could run Java on a Google Cloud Function, which you can do. It's a little bit of a hack at the minute, but I think they're working on more native support, so we're waiting eagerly to hear more about that. And there are more providers, right? So here's a short list of a few that I know of. So Amazon and IBM are the ones that have native Java support at the minute, hence the little J. There's a Google one, there's a Microsoft one on Azure. There's a very interesting thing called Fission. I'll give you a link to that later on. Fission and Kubeless are sort of similar. They're Kubernetes based. So if you have a Kubernetes cluster, you install like 2 or 3 services on your cluster, and you have Fission. So they don't have a hosted service for that at the minute, I don't think, but you can quite easily set it up given a Kubernetes cluster. And all of them, for some reason, the first thing they do is Node.js. So they can all run Java via some sort of JRE launcher. Some of them make it more difficult than others because you not only need Node, you need the JRE, right? You need the JDK to be on the container that's running your function. So working out how to do that is a little bit fiddly for some of them. For Fission, incidentally, Fission has the concept of what do they call it? I think they call it an environment, and so you can define a custom environment called Spring, which does whatever you want. And so in our proof of concept, we made one that runs a Spring app through the Node JRE launcher. So that, to the user, it just looks like Spring. They don't really care, right? They've just, whoever provided the platform has set that up for them as an environment. Okay, so let's get real. Let's see what it would actually look like if we were going to do something with Spring. So one thing you might think about, or we thought about, when we first started thinking about functions, was the JDK. All right. Now this conference has been full of functional programming, reactive this, reactive that. Serverless doesn't have to be reactive, but it sort of is naturally, right? Because it's events. So you're reacting to events, and something happens in response to an event. So this is kind of a proposal, I suppose, that we're making. It's something that's in the Java language. It's in not the language, but the JDK libraries. So Java util function is the name of the package, and it's got these 3 things in it. You've probably seen them before, but I'm just going to remind you, just so you've seen before I start using them. You've got a function, which is a transformation of T to R with a method called apply. You've got a consumer, which consumes things and then returns void. And you've got a supplier, which doesn't need any arguments and gives you a T. So those are sort of the basic building blocks, if you like, for a function, business service function, right? So I can write my business logic using these interfaces, let's say. So if I need to transform something, then I'll write it as a function. If I need to accept an input but not return anything, then like if I want to, post a new item into a repository or something like that, then I'll use a consumer. And if I want to get a list or an item or a stream of items, then I can use supplier. So what would that look like? Let's see. So here's a random properties file that you can ignore. An empty Eclipse workspace. Hope you can see it all. I'm going to create a new project. Or I was going to. Here we go. So it's a demo, and it's going to have web stuff in it, and I'm going to, just to get the POM, I'm going to include a cloud thing and maybe an actuator. Actually, no, I'll just keep it as simple as possible. I'll just make the web stuff for now. So it's a Spring Boot application. Everybody knows what's going to happen, right? We've seen endless demos like this. So what's new is, oops, I didn't want to do that. I wanted to do that. What's new is, I want to think about what would happen if my business logic was a bean. Pause while I wait for Eclipse. There we go. Yes, it is there. There we go. So if we had a public function, let's say, of foo to bar, called foobar, and so to satisfy the, there we go, Java util function, I need to import that, and I need to make a class called foo, and I need to make a class called bar, and now that's going to compile. And now let's define the function. Return foo gives me, oops, new bar. Let's say foo is going to have a name, and that's a string, and I'm going to turn it into uppercase. Okay, simple. Everybody does uppercase for some reason in serverless demos. It's a tradition that I'm happy to continue. But it's important that I'm using POJOs though. That's nice, right? Because we like to work with strongly typed objects. So I'm going to make a string. I could do the same demo with string, but I find that kind of a bit anemic, a little bit weak. So string name, getters and setters. I'm not going to cheat like Josh did. Not that I don't like Lombok particularly, but not everybody understands it. Who uses Lombok? Oh, loads of people. Oh, okay. I could have done. Yeah. I don't mind using it in apps at all. I kind of don't like it when I see it in frameworks, but that's just me. Okay, so I need a constructor. And then we're done. Okay. So that's nice, right? I've got business functionality expressed as a function, and it's Spring, so it's a bean. We're ready to go. Except we're not, right? Because if I run this app, nothing, right? I mean, nobody knows how to run this function for me. So what I need to do is add another dependency, which the initializer doesn't know about, so I can't use the GUI. So I'm going to add cloud, Spring Cloud function web, all right? Well, that'll give you a clue that there are other things that I can play with later. Build minus snapshot There are no releases at the minute. I also need, because I'm using Spring Boot 1.5, I need to upgrade the reactor because we use it internally. Spring Boot 1.5 doesn't work. So Spring Cloud Function works with Spring Boot 1.5 at the minute. OK, so let's see if that does anything. So if I run that app, run as Spring Boot application, fingers crossed, demo gods, please smile. Oops. So it's running. It's running in Tomcat because it's just a normal Spring Boot application, right? What can I do with it? Let's see. Let's try. Don't need rabbit. Let's try curling it. Localhost 8080. What did I call my function? Foobar. That seems like a good path for a web resource, doesn't it? So let's try that. And I want to send it a foo. And a foo is a name called whatever I want it to be called. And I'd better make sure that when it arrives, it knows what type it is. I could probably work out a way to skip this later, but at the minute I know it's necessary. OK, so I'm just going to curl some JSON into that endpoint. And, fingers crossed, there we go, it comes back. Uppercased, of course. It also comes back as an array. That's interesting. You'll note that, and we'll talk about it later. Cool. So basically what I did was created my business logic as a function. At that point in time, I had no need to even know that it was going to be a web service. All right? But I made it into a web service really quickly, Spring Boot magic, using a dependency. OK, so to show you what that could do, in addition, let me try something else. So let's say instead of being a web application, I want it to be a messaging application, a stream listener. So there's a Spring Cloud function stream. And then I'm going to have to add Spring. It's so slow. I'm going to need to add a Rabbit dependency so that I can talk to Rabbit. I could choose Kafka or the other stream implementations. So there it is. So I've got two dependencies there, one which is generic for streams and one of which is related to Rabbit. So I'd better start Rabbit. I use fig as an alias. It's Docker compose. I might as well just do it properly, I suppose. Docker compose up. Just starts Rabbit. So I can prove that Rabbit's running. Look at the management endpoint, and those are the standard exchanges. Okay, anybody know Rabbit? Use Rabbit? Enough. Okay, trust me, the people who don't use it, that's what you see when you start Rabbit. Those are the names of the places you can send messages. Now, at this point in time, with Spring Cloud function, I need to add a bit of configuration, so let me just do that. So I'm going to tell it about the input and output destinations, basically, foos and bars. So that's telling it where I want to hook my function up. So function's input coming from foos, output goes to bars. And I made those names up, right? Which is actually why we need you to do that, actually, at the minute with Spring Cloud Function. We haven't thought of a default naming strategy that works. But if I was to run that application now, if it actually starts, which it should, then you would see a couple of things here. AMQP inbound channel adapter. Hopefully you can all see that. So it's listening for messages. And there they are, look. Foos and bars both showed up as exchanges, so I can send messages to both those places. The foos one also has a queue that it's listening on. Okay, that's a binding to a queue. So that's the thing that it's listening to. My little function is listening to this queue. So I'm going to try and send it a message. So I have to try and remember how to do this exactly. So I need to create a new queue so that I can listen to the result. Otherwise, I'm just sending it into the void, right? It sends it to bars and nobody's listening. So if I make a new queue called demo and add that, and then I want to bind it to the bars exchange, the output exchange, from exchange bars with a default routing key, just bind it. Oops, resource locked. Why? Oh. No, that doesn't make any sense. I'm not exclaiming. I wasn't trying to. I must have clicked on the wrong queue, did I? Yeah, I clicked on the wrong queue. I was supposed to just create one, and I didn't, I think. Is it there? Where's my bar? Demo, I had a demo. Oh, that one. Right, just clicked on the wrong line. All right, okay, very good. I clicked on the wrong line. So easily happens. You go blind when you get up here, I tell you, it's the lights or something. Sorry, yeah, so I'll do what I was doing there. Bind it to bars, default routing key. So now I can sit and watch on that queue and see if anything appears in it. All right, so I could get messages. There are none at the minute. There are no messages waiting. But I can go here to foos, and I can try and create one. So if I do some nice JSON here, I think this is going to work. Trust me. Hello, Barcelona. Try and spell it correctly. Okay, so let's try and send that. That was published. Let's see if I can then get the message here. So this is the transformed message on the other side, right? I was listening to bars. There we go, uppercased. So my function's working, and I've shown you that the same business logic can be repurposed just by changing the class path, and that's nice, right? It defers a choice, it's an option. So that's really the value proposition, I guess, here. First thing is, it's a function, so we can easily map it to AWS Lambda, Google Compute, all that sort of stuff. And second, I already know how to hook it up to web endpoints, stream endpoints, and other things. So that's the same thing, but a function of string to string, where I just do the value to uppercase. So this is the one that everybody does in their serverless demo. So that's sort of almost all you need to know about Spring Cloud Function, but I'll go into a little bit of detail. What you just saw was this, okay, HTTP sending data to a web endpoint. This is the first demo I did. And that was being forwarded to the user function and is all sitting on top of a Spring Boot stack. So here's a slide specifically about Spring Cloud Function, what we aim to do, what we believe we can do, some of what we believe we can't do. So this is what we want. We want to have all of those nice things that you get from serverless, from the Amazon Lambdas and the Google Compute functions, but with Spring, right? So dependency injection, integration if you need it. Kenny Bastani showed me a demo yesterday, which is really cool, where he had an actual Amazon Lambda connecting to MongoDB. Why would you want to do that is a good question. But I think I know the answer. It's actually really interesting. If you looked, does anybody at Kenny's talk yesterday, wasn't it? Anybody see Kenny? He was talking about events. He had a diagram of a microservice, one of those hexagons, and then it kind of spat out this little cloud of functions behind it. It's like it's traveling through space and it's spitting out functions or something. And he said an interesting thing. He almost said it in passing, but he said, "That's my microservice." And it was about 5 things. So it's not just one thing that you deploy now, a microservice. It's potentially, because it's all the same business domain, right? So his little Lambda function accepts an event, a rating event for a movie, and publishes it to MongoDB. And then the main service, with its user-facing features, can then access the database. It's all the same domain. It's all the same business domain. It's all the same microservice. But it's got multiple different deployable units. And that's good, because you can change them and deploy them independently. Same reason that microservices are good. OK, sorry, I stopped myself halfway through the sentence there. Integration, auto-configuration, so Spring Boot magic you can apply, and all your build tools. And that's important, right? Because you need to test. Just because it's simple business logic doesn't mean you don't need to test it. So you need to have a continuous delivery, CI pipeline. That's one of the things that Kenny was showing me, actually, with his functions. And another thing that we want to be able to do is to be able to run it locally, right? Like I just showed you on my laptop, I can run that app, and then I want to be able to take that and then take the same code, ship it off to Amazon, and it does the same thing. So for Spring devs, you've got a really small step, or even a set of small steps to get from your typical microservice to something that uses functions as well, just using normal Spring programming models and using all the function as a service stuff that's new to you, but with the old programming model. And then also, we want to appeal to what I'm calling functionistas, the new, hip, trendy people who don't know about Spring, but they do know about Lambda. They don't need to know about Spring. They just need to be able to write some business logic and do it in Java, and then test it, all right? So those are the people we're aiming at. The main business value, the main value proposition I hope you've seen is that you've decoupled the business logic from the runtime platform completely. You write the business logic in a very self-contained, stateless way that's easily testable, and everybody can agree what it does. You don't actually even need to know Spring. Right, that's one of the things that we wanted the functionistas to be able to do. So you can literally just write a class which is a function, don't even need to annotate it with that component or anything, and we can scan for them. So this is the point. You decouple the life cycle of the business logic from the glue that you apply at runtime. So the integration, whether it's a web endpoint, whether it's behind an API gateway, whether it's authenticated, whether it's all of those things, rate limited, those things. And so what we can do then is hopefully give you a uniform programming model across all the serverless providers that already exist, but also the ability to run the same code standalone, locally, if you want to, on your laptop, or also on a standard PaaS, the layer below the function as a service. OK, so let's just change direction a little bit. Everybody's seen a reactor now, right? Flux and Mono. And Mono is not a monkey, as Josh has told us. But they are both publishers from reactive streams. So we got to thinking. We'd written a bit of Spring Cloud Function. We were thinking about how it should behave. And one of the things we were thinking was, this doesn't really apply in Amazon Lambda, but if you're doing an event stream, if you're processing events, effectively the stream could be infinite. You don't know how many events there are going to be. And that really maps quite well to this Flux. Okay, Flux can be finite or infinite, but it doesn't mind being infinite. So we ought to be able to express that somehow in the same natural way. So you can. You can write a function, a bean, which is a function. Instead of string to string, you can say flux of string to flux of string, or flux of foo to flux of bar. And one of the reasons you might do that is because, like I said, you can then start to listen to infinite streams of things and just do transformations. Another reason is because you can do this kind of thing. You can operate on the stream as it comes in. Even if it's finite, you can more easily express that concept, filtering out things or changing the cardinality. You can more easily express that with the Flux API than you can with a normal domain object, foo. So I'm filtering out rude words in this example. I won't show the demo. It's the same, but all I do is add the extra generics to the signature of the function. But it does kind of explain why I got an array back from my web endpoint. Now, at some point, we might think of a way to deal with the web content management in such a way that if you send a single item and we know that your function can only produce single items, we probably should only return a single item, right? I haven't quite figured out how to do that, but I'm sure it's possible. At the minute, everything is under the covers. Everything is a flux. So we're taking this and turning it into a flux, but we're not unconverting the output yet. That explains why that's an array, because this idiom is useful. I don't have time to show demos of the other things, but if you have a consumer if it's a stream listener, then it's just an HTTP. Sorry, it's a stream sink. A consumer consumes things and then doesn't return anything. And for an HTTP endpoint, that's something you post in, but you don't get back a result. You get back just a 204 or something. And a supplier is like an HTTP GET or a stream source. So it's a source of events in a stream. That's a picture of the second demo I did, where the message came in to the stream layer. I didn't demonstrate it, but in the same app, I could have had the web endpoints running as well. Spring doesn't care about that. You can expose those functions to as many handlers as you want to. And if I showed you the Amazon picture of that, then it would look like this. There would be, instead of Spring Cloud Function Web accepting the HTTP or message input, it would be an adapter, the native provider from Amazon, Google, Microsoft, whatever, and then that would hand the data down to some sort of adapter in Spring Cloud Function, which then would invoke your user function. So I'm not going to show that end to end, but let me just bring that to life for you. I'll have a look at assuming I can actually connect to the Amazon console. Okay, here's my Amazon console. Here's Lambda. I have a couple of functions. One of them is called foobar, surprisingly. So this is the same code, basically, that I uploaded earlier. Somehow I lost its trigger, but you can, let's see what's the best way to show you this. I can configure test event. So I can test it, right? This is one of the features of the UI. I can create test data, and I can test the function without any integration. So there's no event, actually physical event generating this. It's just a test. But it does create a Spring application. There we go. Look, there's Spring starting. And the result is hello world. If I do it again, it's much quicker, you see, because they keep it warm. So, if it's idle for too long, then they just shut down the container and use the resources for somebody else. But if I keep testing it, I'll get roughly 100 milliseconds. They don't bill for any less than that. This is 600.61 milliseconds. It's really fast, but they billed me for 100. So that shows you how it basically could work. We haven't finished these features yet, so we haven't even got them in the public repo. They are in a public repo in Mark Fisher's personal GitHub account, so you can probably poke around and see what we're doing there, but it's not quite ready for prime time. I got the demo working, so I'm happy with that. But it's the same basic picture that I did here. You change the dependencies, you repackage it, you ship it up to Amazon, and it's the same business code. OK, so that was Amazon Lambda working. I think I'm almost out of time, which is good, because this is kind of the last slide. So Spring Cloud Function, this is a feature list. So we had the kind of manifesto, what we want to do earlier on. This is what we, in concrete terms, what we see happening. So we have a programming model, which is basically a bean of type function consumer supplier. Right? That's what you do at the business end. You can have component scanning for functions. So that's the example where you don't have any Spring dependencies at all. You could just build a jar file, put some function classes in it, and tell us which package to scan. We also have a nice feature that Andy Clement wrote, which is, I don't know whether it's more than a demo at the minute, but it makes a really good demo, because it's just like the Amazon Lambda GUI experience. You go into that GUI and you create some JavaScript in a text box in a graphical user interface. You hit submit, and then it's a function. Well, we can do that with Java function bodies as well, because we can compile them on the fly into bytecode and just insert them in the class loader. We also have a sort of prototypical feature at the minute, which is a deployment model. So it's basically to do with class loaders. So what we want is to be able to have, picture this, a sort of a container which is running an app, Spring Boot app, which is keeping the JVM alive and warm and listening on a socket, but doesn't have any functions. And then a really simple operation where you just say, OK, I want you to run foobar, be foobar, and within like half a second, it can flip itself into running foobar. And it does that by loading that Spring application context in an isolated class loader. And so we can use that as a sort of building block for function as a service if you wanted to write your own kind of thing. And then the last thing I showed you a little bit of, I showed the demo of how it looks in practice, at least anyway. So we want to have adapters for the serverless providers. Amazon is the easiest one to do because they already have Java support. But we probably will provide one or two others, probably Fission, because you can create a Java environment for that quite quickly as well. Probably IBM, because they have Java support. Probably Google, because we like Google. But we haven't done that work yet. So we're just working on an adapter at the minute, which is the Lambda one. So that was it. I might have time for maybe one question. Does anybody have one? It's fine if you don't. You can always ask me later. Here's some links then. So that's the GitHub repository at the minute is in Mark Fisher's personal GitHub space. Actually, something I didn't have time to show, but I wanted to, was the thin launcher. Ask me about that another time. So the thin launcher is a way to write, to package your jar files so that they don't have all of the dependencies in them, but can download them at runtime. And if you can do that, then you can create a container layer, for instance, using that download feature. Or you can change the dependencies at runtime. And that's interesting in the context of Spring Cloud Function, as I've shown you, because changing the class path can change the behavior in quite interesting, significant ways. I can turn a web app into a stream listener by changing the class path. So the thin launcher is good for that. There's a link to Fission. That's the provider I like on Kubernetes. The initializer I use to create the demos. Spring Cloud is a generic link. And the Reactor project is Flux and Mono stuff that we've all been learning about. So thank you, everyone.